Hello. In this session, I'm going to talk about angles. A-N-G-L-E-S, angles. So, what are angles? Now imagine that I have an object like that, irregular shape object. Suppose that I can draw a line on this object. Okay, so a line like that. Now if I take this object and I rotate the object, what happens to that line? If I rotate that object, the line will also rotate. So it will go to a different direction, maybe that. If I rotate the object by about that much. So if you look at this line, at first it is there. After I rotated it, it points in a different direction. Now between the original direction of the line and the new direction of the line, there is this corner here. Alright, if you draw these two lines, these two directions, they meet at the center. And this thing here is called an angle. The angle is just a way to tell us how much we have rotated the object. So, but in mathematics, we often just look at the two lines on their own, like that, and we don't really think about a rotation on an object. We would often just look at two lines and try to calculate the angle. So if I just draw two lines like that, this thing between the two lines is called the angle. Now, we need a way to measure the angle. Now when we say measure, it's a mathematical way or a more accurate way to tell us whether something is bigger or smaller. That's what you do when you measure the length. We measure the length in order to tell us whether this length is longer or shorter than another length. So in this case, to measure the angle, we need some numbers to tell us whether an angle is bigger or smaller. So what does it mean when an angle is bigger or smaller? Right. Well, if I have another angle like that, that would be a smaller angle than this. Okay? In terms of rotating of an object by a certain angle, this just means that I rotate less. Okay? And if I rotate more, this sort of gap between the two lines will be bigger. So that's a smaller angle, that's a bigger angle. Okay, now there are different ways or units to measure angles. So we have units like we have for length, where we use centimeters or meters. So in angles, there are a few different units that we need to learn. Okay, the simplest way to measure an angle might be to think about rotating the object again. If I imagine that I rotate the object completely by one turn, if I rotate it completely by one turn, then this line there, it would go round once and it will come back to the same direction. So that's one revolution or one complete round. Right? Now let me describe this one complete round by calling it one revolution. It just means rotating it one full turn. Right, so it means that if I take these two lines and if I open it up, the angle gets bigger and bigger. And if I just go around one complete round back to the same direction, I call that one revolution. So how would I represent that? Okay, let me draw a range of angles of different size. So as you see, that's smaller, that's bigger. Now that would be even bigger than that one. And if I do this, that's even bigger. Alright, that's an even bigger angle than this. Right, I have opened it up so that it bends down. No, this way. Okay, let's make that even bigger. So one go around there. And it can continue to increase until the two lines point in the same direction again, so that we have an angle that goes all the way around. So that's what I meant when I say one revolution. It's a bit a rather strange way of drawing an angle. One line with a little circle around it. Normally we would think of an angle as something in between two lines and meet at a point. But here we just get a single line because the two lines point in the same direction again. So I call that one revolution. So you might think of revolution as a kind of unit. If you do that, then we can think of the smaller angles as a fraction of that revolution. So for example, that angle there, that smaller angle, it might be, for example, 1/10 of a revolution. Just going to use ref for the short form. Okay, that might be a bit bigger, maybe 1/5 of a revolution. That would be much bigger, that maybe say 0.9 of a revolution. For example, so in this way we have a unit to measure the angle. We call it a revolution, and that is used quite often. But the most common way to measure angles is to use a unit that is called degree. You might have heard of that already. So a degree is a very small part of a revolution, and in fact the one way to understand what a degree is to start by learning that one revolution corresponds to 360 degrees. So in a way, that is like a way to define, a way to specify what degree means. The meaning of degree is just that if you have 360 degrees, it means one revolution. Okay, and we represent degree by this symbol, a tiny circle which is placed higher up next to the number. And in English, it is degree, D-E-G-R-E-E. So 360 degrees, plural, if you like, you add an S. Okay, so 360 degrees is one revolution. Now what does that mean? 360 degrees is one revolution. So what is one revolution? It just means that, if 360 degrees is 1 revolution, what is 1 degree? So if you imagine that you take the 1 revolution and you divide that up into 360 parts, each part would be 1 degree. So how do you divide up 1 revolution? Well, this is how you do it. 1 revolution is what you get when the angle opens up until it goes all the way round. So if you want to divide that, you start with smaller angles and you start cutting up this 1 revolution of the angle into small angles, small equal intervals of angles. Alright, and you have to divide it up into 360 equal angles. Now you can imagine 360 is quite a large number, so each of these little parts would be quite small. So I haven't really drawn all 360 parts of this revolution, but you get the idea. So 1 degree would be just one small part of that. Okay, this is just for illustration, so that might be 1 degree. Now to get an idea of what 1 degree is, you can look at a protractor. So you might already have a protractor. It is a thing, if you like, a tool to measure angles, just like ruler is a tool to measure length. So a protractor is a tool to measure angles. Now it looks like this. Looks like a semicircle with some lines from the bottom center and with markings around it like that. Okay, so you might have seen one of those, usually made of transparent plastic. So you would put this protractor here, so put this point on this point and put this line on this line, and then you can measure this angle by reading off, say if I have one line here and one line there, by reading off the markings on the edge, the round circular edge of the protractor. So let me spell that. A protractor is spelled P-R-O-T-R-A-C-T-O-R. Protractor, and a protractor have markings from there to there, where that point at the center is the corner of the circle. Now, so it doesn't actually go all the way around, right? A protractor goes half a revolution, okay, halfway around. So if we say that 1 revolution is 360 degrees, halfway around would be half a revolution. So half a revolution would be half of 360 degrees, which is 180 degrees. So a protractor goes from, have markings that goes from 0 degrees to 180 degrees. Now how would a 180 degree angle look like? Okay, we have seen what a 360 degree angle look like, that's the 1 revolution. But what is half a revolution? Half a revolution would look like this. If I draw one line there and I do half a revolution, the other line must be there. Okay, I'm going to put a mark there to show that that's the point joining the two lines. So it looks like a straight line. Okay, but if you want to think of this as an angle, then this would be 180 degrees. So some people might describe it as a straight line angle. Alright, so we have seen different types of angles. We have seen small angles, we have seen bigger angles. We have seen angles that go this way and so on. Now let's give some names to these angles. These two angles, if you compare this with this, okay, there is something special about these two angles, the small angle. The special thing is that it gives a sharp corner, alright, whereas those are not really sharp. That might look sharp, but if we look at it from this end, right, it's more like a dent. Now this small angle with a sharp corner has a name. It is called an acute angle. So A-C-U-T-E. That's how we describe this angle, an acute angle. Now that angle, which looks like it grows fatter than the acute angle, is called an obtuse. Let's see. An acute angle and obtuse angle. That's right. Okay, and this angle, 180 degrees, some people might call it the straight line angle. Now that angle, where if you compare this angle with the straight line, okay, you can see that that angle is more than the 180 degrees. So it's as if the two lines making up the angle become straight, and then it sort of bends upwards. And we call this a reflex angle. Okay, and that would be a reflex angle as well. And then this is just one full revolution. Now there is one more important angle, and that is the right angle. The right angle is an angle that is 90 degrees. Now it is special, and you can see it quite often in squares and rectangles and triangles. Let me find a space to draw it. Okay, let me draw it here. That is what it looks like. 90 degrees. And we often represent it by a tiny square at the corner. So a 90 degrees angle is an angle that is 1/4 of the full revolution. It is half of the straight line angle, half of 180 degrees. It is like the corner of a square. Okay, it is the angle at the corner of a square. And it is 90 degrees, and we often represent it. We usually show an angle by drawing a tiny arc at the corner. Now because this 90 degree angle is quite special, we have a special way of representing it. Instead of drawing a little arc at the corner, we often draw a little square at the corner. So if you see the little square there, it means that it is 90 degrees. And in fact, it is also called the square angle. And sometimes the word square is used to describe a 90 degrees angle. So if you want to make two lines square, it means that you want to join them at a 90 degree angle. So these are the different types of angles. Right, so we have seen that when you have one full turn, we call that one revolution, and when you divide one revolution by 360 parts, each part is called a degree. And so the degree is a unit of the angle. Alright, we have 1 revolution is equal to 360 degrees. And degree is represented by the little circle up there. So that's the unit for 1 degree. Right, 1 degree is 1 with a little circle. So degree is a unit. We can think of revolution also as a unit. Now there is a smaller unit of angle, a unit that is smaller than the degree. For very accurate measurements that people sometimes have to do with angles, they have to use units that are smaller than a degree. So it's like if you want to measure length, you can have meter. So 1 meter is about this long. But if you want to measure shorter length, you would use centimeter, which is about this long. But if you want to measure very small length, you might use a millimeter or even smaller. If you want to measure the size of a bacteria, you would use 1 micrometer. Or if you want to measure the size of an atom, you would use a nanometer or even smaller units. Right, degree. For very small angles or very accurate measurements, there is a smaller unit. Now that unit is called a minute. What is a minute? 1 minute is 1/60th of a degree. So that's the meaning of 1 minute. If you take 1 degree, which is already quite a small angle, and you divide that up into 60 parts. So you can imagine that each part is very small. Then each of these parts is called a minute. So it's like you have the clock. When the needle goes 1 round, it is 1 hour, and you divide that into 60 parts, then each part is called a minute. Except that here the degree does not go 1 round, it's just a tiny angle, and you divide that by 60 parts, each part is a minute. So a minute is a really small angle. And there's a unit for it. That's 160 degrees. Now, the minute is represented by 1 with a little comma on top. So 1 with a little comma there is a minute. Now there is a unit which is even smaller than the minute. So this is for very accurate measurements or very small angles. Let me write that down. It is called 1 second. It may not be surprising. If you have minute, you have second, right? And you can imagine how that is related to a minute. How is a second related to a minute in a clock? Well, 1 minute is 60 seconds on a clock, and the relation here is the same. Alright, the same relation is used for angles. So 1 second is 1/60th of a minute. So it's a really tiny angle, and the symbol that is used is 1 with 2 commas next to it. So, and 1 minute is 1 with 1 comma. Right? So this will be 1/60th with a comma. So that's how it is written. Now, but how do we use this? So suppose that we have to measure a certain angle very accurately, and this angle might be, say, a little bit more than 15 degrees, but less than 16 degrees. so it's 15 point something degree. And in fact, that's one way to measure it. We can use decimal place, but we often also use minutes and seconds instead of the decimal place. So it's like when we tell time, instead of saying 1.5 hours, we say 1 hour and 30 minutes. So for example, if I have 15.5 degrees, I can also call it 15 degrees and 30 minutes. Right? In fact, 15 degrees and 30 minutes is actually 15.5 degrees. Alright. And this is how we would write it. 15 degrees, 30 minutes. And what if I have seconds? I will just add the seconds next to it. So for example, I might have 15 degrees, 30 seconds, and 15 degrees, 30 minutes, and 25 seconds. So that's how I would add to it. And if you're seeing this for the first time, it is confusing because we tend to be more familiar with decimals like 15.5 degrees. So we would feel better, we would feel that we understand this meaning better if we can somehow convert this to decimals. So how would we do it if we have this 15 degrees, 30 minutes, 25 seconds? What is it in decimals? Or how do we convert it? So let's try converting that. Let me clean this. Right, so first of all, we can look at each of these one by one. Right, 30 minutes, if I have just the 30 minutes, how do I convert it to degree? What is 30 minutes in terms of degrees, or as a fraction or decimal of the degree? And the way to do it is the same as the way we treat units of length or time. It's the same as the way we convert, say, from, or similar to the way that we convert from centimeter to meters. So for example, I know that 1 minute is 1/60th of a degree. So 30 minutes would be 30 times 1/60th of a degree. So that's the way we do it, because 30 minutes means there are 30 of these minutes, and each minute is 1/60th of a degree. So there are 30 of this 1/60th of a degree. So therefore it should be 30 times 1/60, and 30 divided by 60 is just half, which is 0.5 of a degree. So we have 30 minutes in terms of degrees, so we can understand minutes now. 30 minutes is really just half a degree, which we already know. How about 25 seconds? Alright, so 25 seconds. Now 1 second, if you remember, is 1/60th of a minute. So 25 seconds is 25 times of 1/60th of a minute. If I now want to convert this to degrees, I need to convert the minute to degree. So I would make use of that relation, that 1 minute is 1/60th of a degree. So I would then say this is 25 times 1/60th of a minute, and the minute is in turn 1/60th of degree, so I times 1/60th of a degree. So there are three fractions to multiply together. You might use your calculator to do that, and in any case you can then calculate what this is as a decimal or fraction of a degree. So with this you have a decimal for the 30 minutes, a decimal for the 25 seconds, and you can add this up to give you this in decimals, in decimal of degrees. So that's how we can relate seconds and minutes of angles to degrees. Alright, now there is yet another way to measure angles which is important. Now we will see why it is important later on, but this is the place to learn about these units, and it's the last one that I'm going to talk about today, about units of angles. And this unit is called radian. Alright. Now the radian is defined in a rather curious way. If you remember what the degree was and what the revolution was. Revolution is when you go one round around a circle, and that angle is one revolution. If you divide that into 360 parts, each part is a degree. Okay, so going one round is 360 degrees. So those are the more familiar angles that we use in everyday life. But what is a radian? Right, let's try to understand that. Now, imagine drawing a circle, and that this is the center of the circle. Alright, suppose I have a circle and that is the center. I draw a line, a horizontal line from the center to the circumference of the circle. So this circumference of the circle has a certain length. Let me call that, let me say that again. That's the radius of the circle. Now let me call that radius r. So I'm using the ideas of algebra. I'm just using a letter or symbol to represent this radius. So if you have an actual circle there, it would be the length of that radius. It can be any number of centimeters. Alright, so I'll just call this radius r. It represents the length. Now let me draw another line there. Okay, so the length of that would also be r, and in between there is an angle. Now I'm going to use this symbol, a little circle with a line at the center. This symbol is often used to represent angle. It is a Greek letter, a letter from the country called Greece in Europe, and it is spelled as theta and pronounced theta. So we often use Greek letter to represent angles. So let me call the angle theta. Now I'm going to look at the arc joining these two lines. So this arc here. alright, the curved line along the circle. Now, this arc will have a certain length. I'm going to call that length S. Okay, I'm just going to call that length S. So that's the arc length, the curved line along along the circumference. A short section of a curve along the circumference of a circle is called an arc. Let me spell that. Just call it an arc. Now, if you look at this, you can sort of see that if I have a larger angle, right? This is the angle. If I have a larger angle, then the arc joining the two lines would be bigger. If I have a smaller angle, then this arc would be smaller. So there's a connection between the arc and the angle. And this is how we define the angle in radians. Theta is equal to S over R. So what this means is that if you have a certain angle, then you can find this angle in units of radians by measuring the length of this arc and dividing it by the radius, like that. And if you do that, this fraction will be the angle in units of radians, or just RAD is the short form that is often used. Okay, so at this point it may seem rather abstract or even strange, because how are we going to measure an angle in radian? It looks like if I want to measure an angle, I have to draw a circle, I have to measure the length along the arc, and I can't do that with a ruler. I can't do that accurately. A ruler just measures straight lines, and then I must divide that, and it's so troublesome just to find the angle. Why don't I just use the protractor? Okay, the reason is unfortunately beyond what we are going to learn in this course. I would just say that using radians is a lot more convenient in when you start doing more difficult mathematics, particularly a type of mathematics called calculus. Alright, so, or you might not actually be going to that level, but we still need to learn about these particular units here. And what I'm going to explain next is how we don't really need to draw a circle and measure the curved arc in order to find what the radian, what the angle is in radians. There is a way to calculate the angle in these units if we know the angle in degrees. So in other words, there's a way to convert between the units, like we did for say between minutes and degrees, or even between centimeters and meters. So there's always a way to do this conversion, and that is what we are going to learn. Okay, now to understand how to do this conversion, let us look at this formula a bit more to become more familiar with this angle. So let's look at some examples. Okay, one simple example would be to look at the angle for one revolution. Now we know that one revolution is 360 degrees. So what is one revolution in radians? How many radians is one revolution? Okay, so to understand that, let me draw the angle for one revolution. If I have start with a line, okay, and right, let me draw the circle as well. If I have a circle, and this is the line from the center of the circle to the edge. It's not a very nice circle, but if I start with this line from the center to the circle, and if I imagine going one revolution around the center, so this angle theta is one revolution. But what is the angle theta in radians? Now I can find that using this formula. Alright, let's say that length is r. Okay, I did not put in an actual number, but you see that the r will disappear. We can make use of algebra to find the answer to this question. Now if that radius is r, we can calculate the arc S, because the arc in this case is simply the whole circumference, since we are going one round. So S is 2 pi r, which is the formula for the circumference. Okay, so now if I want to calculate the angle theta, I use that formula, S divided by r. Now S is 2 pi r, so 2 pi r divided by r is what we have. Notice that we have r on top and r at the bottom, so they can cancel. We can just divide the top and the bottom by r and they will cancel to give 1 and 1. And we are left with just the 2 pi. So therefore, theta is equal to 2 pi radians. And that is one revolution. So one revolution is equal to 2 pi radians. Okay, so now we have something very definite. We have some numbers here. Okay, pi is not shown as a number, but you know how to find it. It's 3.1415 and so on and so on. You can just find it on your calculator. So one revolution is 2 pi radians. Now, but we are really interested in how to relate this to degrees, right? So we know that one revolution is 360 degrees. So now we have a relation. We have a formula that relates 360 degrees to 2 pi radians. They are equal. And you know that once you have this relation between two units, you can use it for conversion. Just like, because you know that 1 meter is 100 centimeters, you can use that to convert between any number of meters or centimeters. So let's remember that. Okay, and let's try some conversion now. So we start with something simple. So the simplest angle is 0 degrees. That should be simple enough. So if you have 0 degrees, you also have 0 radians. Okay, because if you have a 0 angle, then the arc length down here would be 0. Right? You have arc length joining the two lines if you open up the angle, but if the angle is 0, that arc length is 0. So therefore it is a 0 radian. And if you have 360 degrees, it is 2 pi of a radian. Alright, so we'll first look at some simple some simple angles, if we can call them simple. And one example might be 180 degrees. So we know that 180 is half of 360. So therefore, if 360 degrees is 2 pi radians, then 180 degrees must be half of the 2 pi. And half of 2 pi is just pi. So 180 degrees is pi radian. So there we have another example. Now we can carry on from that and find some examples for a simple fraction of the 180 degrees. For example, we can have 90 degrees. Alright, so 90 is half of 180. Therefore, it's also half of pi radians. So 90 degrees is pi over 2 radians. Okay, so that's yet another example. So notice the trend, the idea. I've divided 360 by 2 to get 180. I divided 180 by 2 to get 90. So why not do it again? Right. If I divide the 90 by 2, I get 45. And if I divide pi over 2 by 2, I get pi over 4. So that's another special example. 45 degrees is pi over 4 radian. Now if I divide that by 2, I start getting decimal place. I start getting decimals, right? Because 45 is not an even number. So, and it starts getting complicated. So let me just stop there for the 45. Now let me backtrack to 180. If I want a simple fraction, I can divide 180 by 3. 180 divided by 3 is 60. Okay. So if I divide 180 by 3, I divide pi by 3 as well. So pi over 3. So 60 degrees is pi over 3. So these are the common angles that you're likely to see in your course. And these are the kind of radians, the corresponding radians. Now because you might have to use these relations quite often, it could be useful to remember them. But if you cannot, not to worry, you can always work it out quite quickly. Just go to 180 equals to pi. Alright, you should at least remember that. And then you can start dividing by 2 or by 4 or by 3 to get this. So these are just a few examples, a few of the more common angles that you see in questions. But what if it is not one of these angles? What if it's 25 degrees or 47 degrees? What if it's some awkward numbers like that? How do we find the radians? Okay, so in that case, we need to use this relation, 360 degrees equals to 2 pi radian, as a way to convert between the units. So let me start by writing down what is 1 degree in radian. Now if 360 degrees is 2 pi radians, to get the answer for 1 degree, I can divide both sides of this by 360 degrees. Or you can think of this as, if you think of 2 pi as 360 degrees, then 2 pi contains 360 of these degrees, and if I want to find 1 degree in radians, I will take 2 pi and divide it by 360. So that's the answer in radians. Alright, and that's the conversion that we have to use. We can simplify this a little because 360 is divisible by 2. So if I divide that by 2 and divide that by 2, I get 180 at the bottom. And this is pi over 180 of a radian. So that's the conversion. 1 degree is pi over 180 radian. And I can use that. For example, if I have 25 degree and I want to find this in terms of radians, what do? Well, I will go to this formula. 1 degree is pi over 180 radians. So 25 degrees is 25 times of 1 degree, right? And 1 degree is pi over 180, so 25 times pi over 180 of a radian. And then you can simplify that on the calculator. So that's how we calculate the radian, if you know the degrees. And you can also do it the other way around. If you know the radian, you can find the degree. So what is 1 radian in degree? Let's try that. Now 1 degree is pi over 180 radian. Okay, let's not start from there. Let's start from the beginning again. 360 degrees is 2 pi radians. So if I want 1 radian, I can divide this side by 2 pi. So 2 pi over 2 pi is 1 radian. Okay. So 2 pi divided by 2 pi is 1. Then on the other side, I need to divide by 2 pi as well, so that they are still equal. So on the other side, we have 360 divided by 2 pi. So that's the relation between 1 radian and degrees. Now I can simplify that like before, because 360 divided by 2 is 180. So 180 degrees over pi. So that's the relation between degrees and radians. 1 radian is equal to 180 degrees over pi, and we can use this to convert from radians to degrees. If you know the angle in radians, then just multiply by 180 over pi and you will get your answer in degrees. Okay, we will stop here for this session. See you next time.